Hey guys, welcome back to Computational Biology with Python. In this lecture, what we're going to be doing is continuing our computer vision journey, and we're going to look at edge detection. So this is a useful tool if you're somebody that works with, it can be used for a lot of things, but if you're looking at working with microscope images or anything that you want to kind of automate the measurement of cells or pull out certain shapes, the measurement of organelles, anything like that. If you want to, like in my case with using, trying to do root angle measurements, cutting out all the noise and just finding the edges of the root to measure the change in angle would be useful. There's a whole bunch of different things, automated phenotyping that you can do with it. So let's get started first. So if you're in my files, we're gonna rename, I'll save this as edge detection. And we're gonna start by importing CV2. And then we're going to import numpy as np. We are going to import matplotlib.pyplot as plt and matplotlib inline. Okay, so we're going to use an image that we already did, and so well, you can pick any image, you can upload a new one if you want, but funny enough, this mushroom that I used in one of the early videos, I forget what it was, Amanita muscaria is what it's called, and this is actually the mushroom from Mario Brothers, or Mario Brothers is based off of. Funny enough, I'm at my in-laws' house right now, and there's two of them growing out in their lawn. So yeah, I got to see one. They're not edible. Yeah, don't eat them. There's ways you can cook them, but it's like can be pretty harmful. But yeah, anyway, so I'm going to use that image though. So image equals cv2.imread, my cursor here, and what did I call this one? Just mushroom.jpg. You can use whatever image you want for this. I would use a JPG just because it's convenient. Plot imshow image. So remember, we have our weird colors, but we can actually, it's fine. We actually don't need to change the colors. You can if you want to use convert color, but for edge detection, we don't worry about that. So edges equals cv2 canny. We're going to do image equals image, img, sorry. Threshold 1 equals 127. Threshold 2 equals 127. So these are both median values, right? So this is based on the color ratio. Remember, 255 is the max for if you want pure red or if you want pure green, that we did in the previous video. So we're saying the threshold is half that. So now if we do plot imshow edges, we should get very messy, right? So that's with our median threshold values. We can also do different approaches to kind of clarifying that, because it's kind of hard to see, right? You can see the stems were picked out pretty good, but like everything else is just kind of a big blur. So we're going to say med value equals np median image, or MP. And then we're going to do med value. So what this is doing is, okay, let's find, so 62 is our median color value. So it's not half of 255. Our image is darker, so to speak, than using a median of 127. So let's change the lower and upper limits of threshold. So say your lower equals int max 0, 0.7 times our medium value. So this lower threshold then is 0 or 70% of our medium value, whatever's lower. And so for upper, we can do integer min 255 1.3 times med value. And this is the upper threshold, or 30% above our medium value, or 255, whichever is smaller. Okay. So edges equals cv2.canny image threshold 1 equals lower, threshold 2 equals upper, and then we're going to plot imshow edges. So we'll try this method. And it looks worse, right? So we can start to adjust the threshold value here. So let's do edges equals cv2.canny image equals image threshold 1 equals lower, threshold 2 equals upper, and then we're going to add 100 to it. Plot show edges. Let's see how this looks. Still quite noisy. So our best so far has been our first one, and it hasn't been great. So let's try let's look at let's look at blurring as a solution to try to help. So sometimes taking away the starkness of the pixels makes it easier for edge detection. So we're going to say blurred image equals cv2.blur image k size equals 5.5, and then we're going to do edges equals cv2canny image equals blurred image. We're going to say threshold 1 equals lower, threshold 2 equals upper, and we're going to plot imshow edges. Let's see if this does any better. Better. I can see a mushroom, right? So to further improve this, we can try increasing the kernel size. So I'm actually just going to take this right here. I'm going to paste it. And let's try 7 and 7. And oh, getting even. I see 2 mushrooms, so we're getting even better. We can try doing the same thing. So I'm just going to paste it here, and we can try increasing the upper threshold limit. Even better. Like I can start to see some of these dots here, and I can see, like, if we look at the original image, you can see like the grass blades, right? And I'm detecting a lot of these grass blades. This is kind of a sloppy, or a very busy image for me to have used, but not every image is gonna be perfect. So let's try with 100, adding to the upper limit. Oh, there we go. So you can see the difference here. We're really starting. We have 3 mushrooms, right? Is that what we had in our original picture? Oh, 1, 2, 3. We had 4. I didn't see that one up top there. Can you see that one up top? Oh yeah. 1, 2, 3, 4. And we're just getting the edges, right? I'll try one more. Let's actually make this. Oh, let's try having this at 7 and then add 100 and see what happens. Oh, see, that's too much. So let's try it at 50. Maybe somewhere in between, right? 25? 60. So this is kind of that one aspect. That's pretty good. And so if you could, use this to measure stem. You can measure the angle of the stem. You can measure the diameter of the cap. Like I said, it's going to work more or less better depending on your input. Garbage in, garbage out. That's always the way it is. So if you were to do something like micrograph, so you're looking at microscope images, it's not going to be as busy as this, right? And a lot of times they're already kind of like, unless you're using fluorescent microscopy or light microscopy, but a lot of times like electron microscopes and stuff are already black and white or grayscale. So, but yeah, you can see this could be useful if you were trying to set up an automated way to measure the distance between stems or the area around here. Edge detection would be the best way to do it. And also, again, there's an art to it. It's not pure. You have to find your threshold values that are going to be perfect for you to be able to run this. Let's try it one more. Let's do 8 and 8. And then just get rid of this and see what that does. And still, we didn't get rid of a lot of the grass there, but yeah. So, anyways, you can still see the gist of it. But yeah, so that's it for this video. It's a useful tool. There's so much of this that can be applied if you're willing to put the time and save you. Like I said, when I did my spaceflight project for seedling growth, I think 10,000 plus images that I manually measured. And so being able to automate this to a reproducible thing too, because part of the other thing is you don't want to introduce measure person error, right? So if you want something reproducible, like, so if I measure all the angles and then I compare it to somebody else, they might not measure the same way. And so this gets rid of all the human error in it, and is very useful. So thank you for watching. If you are on YouTube right now, please hit like, please hit subscribe. We'll continue on. Our next one, we'll do a few more computer vision things because, like I said, phenomics is the way to go.